Hi guys, really nice to see you all. So, let's begin. One night, I was reading one of my favorite science fiction books called Hitchhiker's Guide to the Galaxy. And as you can imagine, this is a story about aliens and space travel. And in parts of it, they use, by their words, the fastest spaceship ever built that can go anywhere in a part of a second. And it was driven by the so-called infinity improbability drive, which the name came because it was so impossible to be invented. And this is actually how the title of the presentation came out, because this is how I felt about distributed and parallel testing and the lack of tooling. Of course, today we are not going to talk about aliens and interstellar travel, rather than how we can deliver high-quality software faster. For those of you who don't know me, I worked for about 6 years in Telerik and later Progress as QA architect. And part of my job was to design and write scalable test automation solutions. And meanwhile, I was consulting many other companies regarding their test automation efforts and led many trainings. And right now, I'm a co-founder of a startup called Automate the Planet that we do consulting and write test automation solutions. So here is our game plan. Even if you don't have the goal to speed up your continuous integration or delivery, I think you'll find lots of insights regarding your test process and how to improve it. I will give examples from our own company and how we make it possible to deploy multiple times a day. Now I will quote the State of Testing report for 2017 by Smart Bear. 68% of the people want to deploy weekly, daily, or multiple times a day. And here, by heavy tests, I mean tests that take more than 1 second to execute. Usually these are tests like database, UI, API, system integration test. They usually take between 1 second to a couple of minutes. But on average, we can conclude that their average speed is approximately 30 seconds. In the different channels, Automate the Planet has over 30,000 followers. And we asked them to participate in a short survey. And I will use the data from it to summarize the practices from more than 50 companies. The first question that we asked our followers was, how many tests do you have? Here I summarize the results in the chart, and as you can see, half of the respondents mentioned that they have between 500 and 1,000 tests, or approximately 750 tests. And if we take the previous mentioned number, 30 seconds per test, this makes 6 hours to execute all of these tests sequentially on a single machine. However, this is a problem to execute all of these tests in continuous integration or to use them for continuous deployment. And why is that? Because, if you want to deploy daily, you want all of your tests to run at least 2 to 3 times a day, or under 3 hours. However, many times there are bugs in the tests, or there is a problem like random environmental issues occurred in your environment, and you need to be able to repeat the whole process again and again. So our second question was, when do you execute your tests? And actually the results were similar to the results present in the State of Testing report. As you can see, almost 40% of the people mentioned that they already execute their tests in continuous integration. However, if you closely observe the numbers, you will see that almost 60% of the people struggle with the speed of their tests. So I can define at least 3 types of parallel testing. The most obvious one is if you use your native test runner. For example, MS Test, TestNG. Imagine that you have 100 tests and you want to execute them on a single machine with 5 CPU cores. This means that the native test runner will run them in 5 separate test threads or 20 tests per thread. And later on, the native test runner is responsible for merging the results in a single file. This is the first approach. Then the second one is called distributed testing, meaning that you use, instead of the native test runner, complex tooling, so that you execute the test on multiple machines, and later on, the complex tooling, such as Microsoft Test Agents, they merge the results into a single file. And of course, you can mix both approaches, meaning that you use this distributed testing and at the same time run multiple threads on each machine. In our observation, the optimal number of test processes that you can use is equal to 1.5 up to 2 multiplied the CPU cores. For example, most test agents in our observation have 2 CPU cores, meaning that if you use this formula, this will make 4 separate test processes, which means you are limited to the hardware you use. And later on, I will show you a demo to demonstrate that. One big machine or many smaller? To answer to this question, I need to tell you the difference between horizontal scaling, which means that you are adding more machines to existing pool of resources, whereas vertical scaling means adding more power, like CPU or RAM, to an existing machine. And usually, many smaller machines are cheaper than one big one. What are the advantages of distributed testing? Well, the most obvious one is speed, meaning that instead of executing your tests in 16 hours, you can execute them in 4 or less. Also, since you can execute your tests much faster, you will be able to deploy multiple times a day if needed. But even if you don't have this goal, you can always integrate the execution of all of these tests in your continuous integration. And this way, you can improve the overall quality of your product. And of course, you'll have higher test coverage in shorter throughput time. As you know, the more often you execute all of your tests, their return of investment increases. And last but not least, you will be able to locate these flaky, unstable tests more easily since they will be executed more often. In order to understand how our company solved this problem for us, I need to tell you what we needed to test. Our company specializes in creating test automation solutions and tools for testing web, mobile, API, and desktop. And it's not a visual application, rather than a set of C# libraries, tools, etc., built on top of famous frameworks such as WebDriver, APM, WinAppDriver, etc. And because we have lots of integration and lots of features on top of them, we need to test everything that it's working. So to test our framework called Beatrix, we ended up with 4,500 UI tests, only for the web part. And as you can imagine, here, by the way, I'm not counting all of the unit tests, since they are quite fast. And if you run all of these tests sequentially on a single machine, you will need more than 16 hours to execute all of them. Here on the slide, you can see an image from our Azure DevOps CI job. So this was unacceptable for us, because we want to be able to release updates multiple times a day. This is why we created an open source free tool for distributed testing called Misa. And it's built using the latest .NET technologies, such as .NET Core, ASP.NET Core, and more. But more importantly, we designed it in a way that it's programming language agnostic, meaning that you can run tests not only written in C#, but for example, on JavaScript, Java, etc., using extensions. What are the most prominent features? First, as mentioned, it actually used the third type of parallel testing, meaning that it can distribute the tests across multiple machines, but at the same time run the tests in multiple threads on each machine, and then it's responsible for giving you a single result. But moreover, it has the feature for smart balancing, meaning that it will use the previous test execution times of the test and then balancing them more smartly. Then it's important, your runner, to have this failing retry logic, meaning that sometimes there is a problem in the test and you won't be able to understand whether there is a bug in the system under test or bug in the test. So you just retry the failing tests. Also, no more complex installations, meaning that it's just a command line tool. Also, it has extensions specially built for UI tests, meaning that it will kill browsers, WebDriver instances, Appium instances, etc. And since it's built on .NET Core, it's cross-platform, meaning that you can run tests on Mac, Linux, and Windows. So before Misa, we had, as mentioned, 4,500 tests that run for 16 hours. And with Misa, using 4 test agents, we were able to decrease the time under 4 hours. How do we use it? In a minute, I will show you a demo that I specially built for Selenium Conf in India. But first, let me show you how we use the tool. First, we have this server, which is like if you have used Selenium Grid, is the same. You need to have a server. So first we start Misa in server mode, which is responsible for coordinating all of the runners and test agents. Later, on each machine that you want to run tests, you start Misa in agent mode, which is actually the process that runs the tests. It's important here to point the IP address of the server machine, pretty much the same as Selenium Grid. And lastly, from your continuous integration job or just from the command line, you just start Misa in runner mode, pointing where your tests are located, where the results will be saved, etc., and mentioning the test technology. Because as mentioned, it supports multiple technologies like Protractor, C#, MS Test, etc., and you need to point which plugin to be used. So now I will show you the demo. Okay, so before proceeding, what is the goal of the demo? I want to demonstrate that we are limited first to the hardware we use. As mentioned, if you recall the formula, here I will use 11 virtual machines in Azure. One of them is like 5 CPU cores and 4 GB of RAM, each one of them. On one of them, if you recall the formula, the optimal number of test processes is equal to 6 and 8, but one of the tests will start 16 processes, and we will see what will happen. Here, because I didn't want to show you only unit tests, I built a special project that will actually run 100 UI tests. And to be more real, I created a demo application which simulates a shopping cart using Twitter's Bootstrap. This is what one of our tests will do. It will fill the shopping cart and submit it. In normal circumstances, on a normal machine, this test will take between 6 to 8 seconds. So as you can imagine, 1,000 tests will be executed for something like 80 to 90 minutes if we run them sequentially on a single machine. This is our test. In order to automate it, we will use WebDriver. Here is our project. This is, if you see here, I will open how one of our tests will look like. Here, as mentioned, we will use the native .NET Core test runner, and we will use MS Test to run the tests in parallel to make the comparison. We use this attribute, assembly parallelize 16 workers. This is how we tell MS Test to run our tests in 16 threads. But as mentioned, the optimal number on this machine is 8, meaning that after 8 threads, nothing will improve, and I will demonstrate that this is the case. However, what we else do, first in the test initialize that it's run before each test, we actually wrote the HTML file of the shopping cart that I showed you. Then before each test, we need to start a separate instance of WebDriver. However, as you can imagine, since we are going to start multiple threads, if you know how WebDriver works internally, it starts listening on a particular port. However, since we are running multiple processes, if you start a second instance listening on the same port, the second test will fail because of that. And because of this, we need to create a special method for getting the first free port. And we use C# synchronization thread logic. Also, here another important aspect is that we start Chrome in headless mode, meaning that our Chrome browser will start without UI, so that our tests will be much faster. And after that, we navigate to the shopping cart. We wait for the first name element, and then this is like normal WebDriver code for typing the data. And after that, we close the browser. That's it. Then we need an application for generating all of these 1,000 tests. So I created a separate application for that. And this is the application that will generate actually 2,000 tests for for the first demo and then for the second. Come on. So this is our application for generating the tests. And here, this is actually our demo project where our 1,000 tests are located. And as you can see, this is a really huge file, like over 40,000 lines of code. 1,000 UI tests. Now, in the next part of the demo, I will show you actually here in Azure, as mentioned, I created 11 virtual machines. They are all the same, use the same image. On 10 of them, we'll use Misa, and on one of them, we'll start the demo with the native test runner. And here is how one normal CI job looks like using the tool. This is actually our continuous integration for running the tests of Bellatrix framework. First, we get the source code, then we install .NET Core, then we restore all of the packages, build the projects. Then you need to copy all of the output files like DLLs, etc., to a special folder. Then we delete the old test results files so that they are not overridden. And this is how we use the tool, just from a folder where you have downloaded it. In a bit, I will show you how we started. But here, you use the verb runner, and then since we use all of the features of the tool, there are lots of arguments, but the most important part is to mention the IP address and the port of the server. That's it. Later on, when we have the results, we publish them to Azure. That's it. And in a bit, you will see how the test results look like in Azure DevOps. Here is actually the report. Actually, this is our continuous integration. As you can see, it's quite fast, only 3 minutes for running almost 2,000 tests. And actually, these are UI tests because we use for continuous integration Edge browser, which curiously is the fastest one. And here, for the demo purposes, to demonstrate the run on 10 machines, we will again use Misa in runner mode, pointing the server, and we use 6 parallel processes, meaning that our 1,000 tests will run in 60 separate test processes on these 10 machines. This is one of the machines. As you can see, I have started here multiple connections to all of these virtual machines. On one of them, I have started Misa in server mode. I will show you how to do it. First, when you have downloaded the tool, you just need to navigate to the folder and open the command line from there, since it's a command line tool. You can do the same on Mac and on Linux. So here we start the command line, and you just type Misa init server, that's it. And later on I will explain actually how this works internally. This is how we start the server. And then on all of the machines, I will start here Misa in agent mode. Since we use Windows, to make it a little bit more easier, I have created batch files so that there is no need to navigate always to the folder. This is the command to start the agent. Misa, test agent, etc. And using the test agent tag, you can filter on which agents the test will be executed. For example, you can have agents for UI tests, for mobile tests, etc. You can use a single server so that the tests are filtered and executed on the right machine. And now we will start the continuous integration job, and we will observe the results. And now, on the 11th machine, we will start the another project that I showed you with the MS test attribute for 16 processes. To run this test from command line using the native .NET Core runner, you just type .NET test, that's it. And the test will be executed in 16 processes on this machine. I'll just skip a little bit the video to show you only the results. As you can see here, the Misa run finished for 6 minutes. As mentioned, if you run all of these tests sequentially on a single machine, you will need something like 90 minutes to execute them. So this is times faster. And what happened with the other example? Well, it totally crashed. Since, why is that? Because the Chrome driver is loading into the memory, and actually if you closely observe the exceptions and the errors here, the native test runner throw system out of memory exception, meaning that even couldn't cope with this type of load. But even if you manage to execute all of these tests, they were going to be executed for around 30 minutes using a single machine. That's it. And also making the demo, I noticed that if you want to start more than 8 WebDriver instances on a single machine, it totally crashes. So even if you want to do a parallel testing, you cannot. Okay, let's continue with the presentation. In order to solve the problem, besides all of the experience that I have from my past companies, I read everything I could find for a couple of days to prepare. And I noticed that actually for the last 8 years, the ways how people run their tests in parallel has not really changed. Here on the slide, and you can see, we are actually asked this question our followers. So I summarized the results from the survey, from the state of testing report, and from what I read. So as you can see, like less of the people use Microsoft Test Agents. Some of them use continuous integration and custom solutions, but almost half of them use combination between native test runner and WebDriver if we are talking about UI tests, of course. And however, using native test runner has a couple of drawbacks. What are they? Well, sometimes, for example, this was the case for MS tests for a long time. You can run tests in parallel only if the tests are located in different containers or projects. And actually, in the latest version of MS Test 2, they released a version that is able to parallelize the tests in a single container. So, yeah, this is a challenge. But even if you use your native test runner, most of the native test runners don't have a way to distribute the tests across multiple machines. So actually, we use them together with Misa so that, for example, we use the native test runner of any unit so that we can distribute the tests across multiple agents. We use the native test runner to run the tests in parallel, and then we use Misa to merge the results, etc. Now, many new solutions actually utilize Docker containers nowadays. One of my favorite tools is Solenoid. For those of you who don't know what Solenoid is, it's basically Selenium grid on steroids, like giving you a way to execute UI tests in separate new instances of browsers in Docker containers. However, it supports only the most major browsers like Chrome, Firefox, and Opera. But it's really a great tool. For example, you can run separate, like multiple containers on a single machine, and the tool will automatically record video for each of them, which is amazing. And I was honored to meet with the developers of the tool on 2 of the conferences in Moscow and in India, and they are really cool guys. And actually, right now, here on the slide, as you can see, I mentioned that it doesn't support mobile, but actually, they showed me a demo that right now you will be able to run Appium in Docker containers, which is really cool. But when we evaluated the tool, when we needed to choose the right tool for our company, we rejected it because it doesn't support like desktop automation, etc. And it doesn't support some of the major browsers that we need to support, like Edge, Internet Explorer, and Safari. And it's not working on Mac, so yeah. However, you can, for example, if you test only on Windows, it's really great. It's open source, so you can build on top of the existing images. It's really amazing tool. The most of the points are valid for the Selenium, for the standard Selenium grid, and it's tuned Russian versions like Selenograph, JSON wired grid, grid router, etc. They're not test runners. Like, even if you have 100 hub nodes, and if you don't use the proper test runner, your test will be executed on a single node, one by one. So you will not utilize all of these machines. So you can combine it with the test runner. Other people, because of the lack of tooling, they use their continuous integration jobs to run their tests in parallel or distributed. Like, the most common practice is to mark your tests with attributes or notations such as machine 1, machine 2, machine 3, and then use your continuous integration job and run these tests filtered on multiple machines. And then you need to find a way that your continuous integration merges the results and giving it back to you. However, this is like unacceptable for me because of the balancing of the test is happening manually, meaning that every time you add a new test or remove existing test, you need to calculate that time in your head. And also you need to find a way to merge the results. For example, back in the days in my team in Progress, we use Jenkins jobs and we use NUnit. And we needed to find some kind of a plugin to merge all of these NUnit results. Also, actually, I'm a big fan of Microsoft. Back in the days in Telerik in Progress, we used most of the times Microsoft test agents. However, they have a few flaws. For example, they are really hard to set up. It's really black box how the tests are balanced across the multiple machines. no need to mention that the documentation is missing almost entirely and that you can run tests only on Windows, right? How Misa works internally? Well, it has many moving parts. As mentioned, it comes like a single command line tool. And here, the server, when you start it the first time, it creates a portable database, SQLite database. Also, a web service is self-hosted on the same machine that the runner and the agents use it to communicate between each other using HTTP. And since the runner and the agents don't have separate databases, the server needs to be up all the time. Otherwise, the whole system won't work. The first time when you start an agent, it registers itself as active and continuously asks the server whether there are new runs to be performed on this particular machine. If there are any, the first thing that we do is to load the so-called extensibility points plugins, meaning that we give you a way to execute logic in various points of the test execution pipeline, like before, after the test run, on abortion, etc. Then, to accomplish the so-called programming language agnostic feature that you can run tests written in different technologies, we use the so-called test technology plugins. Like we have separate plugins for C#, Java, Protractor, etc. So they are important because based on them, we read the tests from the test project, then we use some logic to merge the results, etc. And later on, based on the in parallel arguments, the tool starts multiple test batches, waits the process to finish, and merges the test results into a single file. This is what is happening in the agent. And what about the runner? The runner again loads all of these plugins, then use some logic from it to extract and filter the tests. Then, based on the test agent's count, it balances the tests on the multiple machines, zips the output files, and sends them back to the server, where each agent can download them and later on execute them. And the second part of the run is where the runner actually waits all agents to finish in one thread. In one more, it actually pings the agents all the time to get if there are any messages that needs to be printed on the console of the continuous integration. In one more process, it verifies the health of all agents, meaning that, for example, if something happens with the machine where the tests are executed, the runner will notice and will abort the whole run. And in one more process, it's important the runner to verify its own health, meaning that, for example, if you cancel the build or something else happened with the runner, the agents will notice and will again abort the whole test run. And later on, the runner will merge the results from all machines into a single file. And here, based on the retry failing option, if there are any failed tests here, the whole process will repeat only for them. And if they succeed, the runner will update the test result file. That's the whole flow. And later on, we again execute some logic from the extensions. How to get started? Well, right now, you can download the tool from our website. However, in the next release, we actually built a new feature so that you don't need anymore to download the updated version from there. Actually, you will be able to install it from command line directly. This is really cool for using the tool in Docker. Right now, you need to unzip it and start executing. And besides that it's open source, we have really rich documentation and blog posts. If you want to get involved, we have a really active community in GitHub, because right now there are guys from Russia, Belarus, Ukraine, India that help us to write the various plugins and Docker support, etc. So we use Gitter in GitHub. So there are lots of guys reporting bugs. You can suggest new features. Actually, most of the time, usually people gave us only like test projects. For example, if you want a support for a language that we don't support, you just give us like an example project with tests and tell us how they run from command line, and then we just build the plugin and give it to you. That's it. So if you want to participate, you just go to GitHub and send us a message. In short, I told you about the different types of parallel testing, what are the benefits of using distributed testing. I really liked it. How people run their tests in parallel, about our project, why we use it, and why we build it. And I really wanted to end up with some kind of statistics, but I decided to go even further. So I used a similar application to the one that I showed you before for generating 100,000 tests. Each of them takes approximately 1 second. And if you run all of these tests sequentially on a single machine, you will need 28 hours to execute them. So for this particular load test, this time, again, I created 10 virtual machines in Azure, but as you can notice, they are much stronger than the ones in the video. They have 8 CPU cores and 14 gigabytes of RAM, meaning that if you recall the formula, here we started 16 separate test threads on each machine, meaning that this test will run simultaneously on 160 processes. And this is the time if you run them sequentially on a single machine. And this was the time that we achieved using the Misa project. Here is the actually the continuous integration Azure DevOps build. And I will end up with a quote from the CEO of the most famous programming website, Stack Overflow. It's too long to read. I will summarize it for you. To be great QAs, we need to improve the happiness and morale of our developer colleagues by giving them more frequent releases, and this way giving them negative and positive feedback faster, and this way improving the overall quality of our products. Thank you.
We have time for some questions. I would expect there is more. Okay, we have one in there.
Hi Anton, this is great initiative. Actually, it is long overdue, meaning to have a really good parallel testing, distributed parallel testing. It lacked for a quite long time, and what I'm actually interested in, and believe me, this is a great concept, and it will work great with the containerization, etc. Meaning, if you have stateless environments. But for, let's say, legacy projects, you don't have stateless environments. And one of the reasons you have actually batches of things is in order not only to move them in parallel, but also to make groups of them. And for instance, if I use TestNG, I can embed into the logic of the groups some things. So I would like eventually to see some kind of affinity and anti-affinity rules into your scheduling modules.
Actually, guys from India that we met at SeleniumConf in India, they asked me about similar feature because they built some of their tests, they use Protractor, and some of their tests depend on each other, but only some of them. And because of that, you cannot like run them in parallel. And because of that, we started working on a feature where you can use, again, annotations or attributes so that you can tell the tool that this particular test should be run on only on a single machine and that they are not run in parallel. so the tool will understand them. But however, as you can imagine, because of all of the parallel development, etc., it's really hard to write it right away. But we are working on it.
Great to hear that. It will be helpful.
Yeah.
Thanks.
Yeah, there is another question there.
Hi.
Hi.
First, congratulations for the great tool you just presented us, and congratulations for your talk. It was quite interesting.
Thank you.
I have a question about you mentioned that it balances the tests between the machines.
Yeah.
Is there an option for that to be a configurable, I mean the algorithm of balancing the tests between the machine? Can I, as a user of the tool, configure what algorithm to use to balance between them?
This is interesting feature. Actually, the whole design of the tool, we use the so-called onion architecture, meaning that all of the code is unit testable, and especially this kind of algorithm, we use the so-called strategy design pattern, meaning that we inject the way how the tests are balanced, you know. And actually right now we support two different strategies. One of them is when you don't have previous test execution times, we just chunk the test based on the test count, and we have another algorithm based on the times. Right now we don't support like an argument so that you can change it, because there are only two ways. However, it can be easily added as a feature. Nobody just told me that needs such a thing, but it can be easily added. It's no problem.
Okay, thank you.
Yeah. Other questions or? Okay. I'll go to the room, to the third room. So if you just want to chat or ask me anything, you can find me there. Thank you.